Hello and welcome to the last video of the trimester for Pre-Calc Math 153. Let's get started. So today's topic is on the continuous growth and decay formula, and here's the formula. So the amount that you have is equal to, the initial amount, and then E raised to the K. K is some sort of number that represents how much it's growing or shrinking, and then T stands for time. So again, A sub 0, or we call that A initial, is the amount that you start with. Okay, if K is greater than 0, then you're going to have exponential growth. And if you have K is less than 0, you will have exponential decay. It will be shrinking. And again, this is the amount you have. This is the initial. This is that constant K that tells you if it's growth or decay, and this can sometimes be years or days or hours, depends on the problem. All right, so here's our first problem. It gets wicked hot in Manson in the summer, and because of this, water evaporates from a pool over time. So on July 1st, there was about 5,000 gallons in Mrs. Plummer's pool, and 25 days later, there were 4,200 gallons in that same pool. So I want you first to find the K, that K value, that constant of proportionality, that's what we call K, in the following equation. And then I want you to write a function that models the amount of water in that pool. And T will represent the number of days after the original measurement. And then we'll deal with that last question, but it says, using the model, find when the water in the pool would be at 3,000 gallons. Okay, so first of all, we're going to write down the equation. We've got the amount is equal to the initial and then E to the KT. Okay, so the amount that we have right now is 4,200 gallons. So we're going to write 4,200. And that's going to be equal to the initial. Well, how much did we start with? Well, it says at the start on July 1st, we had 5,000 gallons. Now I don't know my K, so I'm going to write that as K. And then my T is, in this case, the number of days, and this says 25 days, so we're going to have 25. Now I'm simply just going to rewrite this a little bit nicer. We usually are going to write our variable after our number, so we're going to call this 25K. All right, next thing that I'm going to do is divide by 5,000, because I'm trying to solve for K, so we're trying to get K all by itself. So let's get rid of the 5,000. And so 4,200 divided by 5,000 is 0.84. This cancels, and I'm left with E to the 25K. Now you need to think back, how do we get rid of a variable and an exponent if our base is E? Well, in this case, we're going to take natural log of both sides. And you'll see that ln E cancels, and I'm just left with a 25K being equal to an ln of 0.84. And you don't need those parentheses, but c'est la vie. Divide by 25, and we get K equals, and at this point, folks, I actually want you to take your calculator and find what this answer is as a decimal. So our natural log button is right next to the 4. So you're going to do ln of 0.84. And it's necessary that you close your parentheses and then divide by 25. Again, if you forget your parentheses, you're basically taking the natural log of 0.84 divided by 25. But that's not what you want. You want to take the natural log of 0.84, get that answer, and then divide by 25. So I get a negative, and at this case, I'm really happy I got a negative because, remember, our water is evaporating, it's disappearing. So this is exponential decay. So we're happy about this. I'm going a little crazy there. Okay, next step, it says to write a function. So we're going to start with this. So I'm going to have A equals, I'm going to write my initial in there, which was 5,000. And then I have my K. So I'm going to have a negative 0.006974, and then I'm going to write my t. So when I ask you to write a function that models this, you basically have to put in your initial and you have to put in your k value. All right, let's go ahead and answer this final question. It says, find when the water in the pool would be 3,000 gallons. So when would the amount be 3,000? So I'm going to put 3,000 in there. And we're going to be solving for our t. So first step is to divide by 5,000 on both sides. The 5,000s cancel, and then we get 3,000 divided by 5,000, which is just a plain old 0.6. Okay, and then we have e to the negative 0.006974t. All right, at this point, we're going to take natural log of both sides, and we're left with ln. Who knew that was a different color? Can you tell the difference? I can. We're left with an ln of 0.6. Okay, now my ln and my e cancel, and I'm just left with a negative 0.006974t. And my last step is going to be to divide by negative 0.006974. Okay, these are going to cancel, and I'm left with just a plain old t equals. And again, folks, you have to put in ln of 0.6, close your parentheses, okay, and then divide by that negative 0.006974. And I get roughly in 73.2 days. And make sure you can get that on your calculator. All right, I have one more problem for us to do. All right, now let's talk about bacteria. So here's a kind of funny animation down here. Don't anybody touch that chip yet. And then they said, too late. Yeah, it's super funny. All right, so we've got a culture of bacteria in the lab, and the amount of bacteria is going to double every 5 minutes. And that's not uncommon. Bacteria grows really fast. Now, assume the growth follows a continuous exponential model, and you start with only 2 bacterium. First, let's find the equation for this. Let's find the k value, and then let's find the time in which the number of bacteria would reach 10 to the 6th power, which is, I think, exactly 1 million. Yep, exactly 1 million. All right, so first of all, let's write down our equation. A is equal to the initial amount, and then e to the kt. So think about this, folks. If we start with 2 bacterium, we're going to have 4 bacteria after 5 minutes. That's what it means to double. So we're starting with 2, we have 4 after 5 minutes. So the amount that we have is 4. We started with 2, and our time is 5 minutes. So rewriting this, I have 4 equals 2e to the 5k. Next step is going to be to divide by 2. So this gives me 2 equals, this cancels, e to the 5k. All right, next thing we're going to do is we're going to take natural log of both sides, so ln of both sides, and then in this case, our ln2 just stays ln2, but ln e disappears, and I just get a 5k. Okay, so now at this point, I am going to divide by 5, and I get a k value that is equal to ln2, and again, close your parentheses after ln2, then divide by 5. I get a 0.138629.